Hi class. So here is our last diagram for chapter 3. It is on the subject of the greenhouse effect, okay? And it's going to look pretty similar to the previous figure that we drew. So what are the three fates of solar radiation as it passes through the atmosphere? And so we will start off with solar radiation reaching the top of the Earth's atmosphere. Again, just real quick, 7% ultraviolet, 43% visible radiation, 49% infrared radiation. Okay, that's what reaches the top of the Earth's atmosphere. And then once it reaches the top of the atmosphere, it starts to pass through the atmosphere, and it can be reflected, scattered, or absorbed. And if it's not reflected, scattered, or absorbed, it makes it down to the Earth's surface, where it gets absorbed by the surface. Okay, and on a global basis, again, we'll just jot down some notes. So 49% of, and I'll abbreviate here, the incoming solar radiation, 49% of incoming solar radiation makes it to the surface. Okay, and is absorbed by the surface. Okay, so whenever any object, the Earth's surface, absorbs any form of radiation, whatever's left over, ultraviolet, visible, infrared, the object, the surface, warms up. And so the absorbed solar radiation, incoming solar radiation, is converted to heat energy. Okay. So as a result, the Earth's surface is going to warm up. Okay, and if you recall from our radiation laws, though, that the Earth is a black body. So the Earth, being a black body, remember this has nothing to do with the color of the object, the Earth's surface, but the Earth being a black body, and that's radiation law number 2. Okay. The Earth being a black body must radiate all of the energy it absorbed. Okay, and it does this in order to maintain a constant temperature. Okay. And so if it didn't radiate all of it, if it held some back, then the Earth atmosphere system would warm up continually and we would all burn to death. And if it gave up too much, then over time we would cool off and we'd turn into an ice ball floating around in the solar system. So the Earth's surface absorbs solar radiation, and then it has to re-radiate all of that energy back out to space in order to maintain a constant temperature. And so remember, based on Wien's displacement law, so let's see, Wien's displacement law Anybody remember what law that is? Bueller. That's law number 3. Okay. And so based on Wien's displacement law, we know the Earth emits only infrared radiation. Okay. So the Earth only emits infrared radiation. Okay. So I'm going to take a break here for a second, and now we're going to go back to Chapter 2. And what I want to remind you about in Chapter 2 is what's in our atmosphere. So we've got major gases, and again, they're major only based on the amount of the atmosphere that they comprise. And so that's nitrogen and oxygen. So nitrogen is about 78% of the atmosphere. Oxygen is about 21% of the atmosphere. And argon is about 1% of the atmosphere. And then the rest is minor gases. Okay, again, they're minor only based on the amount of the atmosphere that they make up. And most of these minor gases are going to be greenhouse gases. Not all of them, but the vast majority of the minor gases are greenhouse gases. Okay, and so we're looking at carbon dioxide and methane and ozone, nitrous oxides, and chlorofluorocarbons, and there's others, but we'll just keep with those. Okay, and so if I just make a bunch of dots here on this piece of paper to represent the greenhouse gases in our atmosphere, and remember these in total make up approximately 0.04% of our atmosphere. Okay. So there we've got our greenhouse gases. Okay, now back to what we were saying before. So the Earth's surface absorbs solar radiation, converts that to heat energy, and the Earth's surface has to give off all of the energy that it absorbs in order to maintain a constant temperature. And it gives off or emits that energy only in the infrared wave band. Okay, so if we've got infrared radiation, emitted by the surface, and that infrared radiation is trying to make it out through the top of the Earth's atmosphere. However, we've got these minor gases, greenhouse gases in our atmosphere, and we say they're minor in terms of their concentration, but they're really, really important because what they do is they will absorb this infrared radiation that's being emitted by the surface and re-radiate it back to the Earth's surface. Okay, so what greenhouse gases do, so GHGs, greenhouse gases, absorb and re-radiate or re-emit infrared radiation back to the Earth's surface. Okay, so really, in effect, what greenhouse gases do, greenhouse gases, they act like a blanket. Okay, keeping our planet warm. And keeping it a constant temperature. Okay. So literally, greenhouse gases act like a blanket. So if we use the analogy, when you go to bed tonight, you can think of it this way, that your body is like the Earth's surface. Your body is radiating infrared radiation. Okay? And when you go to bed at night, you pull up a blanket, and when your body radiates away infrared radiation, just like the Earth's surface does, the blanket is going to absorb some of that infrared radiation that your body is giving off, and it's going to re-radiate it back towards your body, keeping your body warm. Okay. Now, when it comes to global warming, okay, if we continue in the analogy of the blanket on the bed, when human activities increase the concentration of the greenhouse gases in the atmosphere, okay, that's analogous to going and grabbing a thicker blanket. Okay, so a thicker blanket will absorb even more infrared radiation from your body, just like an increase in greenhouse gases will absorb more of the infrared radiation being emitted by the Earth's surface. Okay, the blanket and the greenhouse gases re-radiate that infrared radiation back to your body or back to the Earth's surface, and it's going to keep the temperature of your body or the Earth's surface even warmer. Okay, and so that's kind of the explanation of the greenhouse effect, and then bringing that analogy even further towards global warming. Okay, so again, if you have questions, as always, let me know. And this is the last figure for Chapter 3. Okay, after this, we'll be on to Chapter 4.